Welcome to my lesson. This is grade 6, middle school grade 6. We are going to use simulation to explain the concept of force to my student. And it will take just 5 minutes explain what is force to my student. So let's get going. Now, middle school grade 6, we are looking at what is force. We have only 3 objectives here. Objective number 1, look at define the concept of force. As you can see the cursor here, define the concept of force and how does force influence or causes acceleration of an object, or how does force influence object to move. We are going to solve at least 3 questions, 2 questions on the concept of force. Shall we go? So I give a progression with just 5 minutes. So what's a force? We are going to define force to grade 6 to ensure that force is a push or pull of an object. If I pick an object like this,
force influence the speed of
and
an
if
object?
it continue to stay in my hand, continue to stay in my palm until the kingdom come, unless there's a push. If I push or I take it away, I've applied a force. In science, anything that comes in the form of a push or pull, is as influence of a force is there. So to my student, a force is as an object which move, which cause an object to move, or which cause something to move. So we say force is a push or pull of an object or anything, every moving object influenced by a force in simple terms. So in science, we say we calculate a value of force by multiplying the mass times the acceleration of the body. The SI unit, the standard international unit, which is SI units of force, is newtons, written by the small n and the abbreviation capital N, according to international standard unit. That's how we write the unit. Thank you so much. The next.
Okay, students, we are going to use this simulation to explain the next objective of the lesson, which is the effect of force on acceleration of an object, or how does force influence acceleration or motion of an object. Okay, to be very quick, this is interactive lesson and I employ you to ask a question and I'll pause and we shall discuss it. So shall we go? If you ask a question, you put up your hand. Okay, these are the value we have. Let's check this and we shall see the effects on the simulation. So this is the speed, this is the time, the stopper. This is the speed or the velocity of which the object is moving. The mass, as you can see, the mass gives you the value of or the masses of the object that are going to be pushed. Okay, so let's start. Now, this is the robot is going to push this object. The robot is going to push. The value of the force here is 50. Let's increase. We can see how slowly it moves, how it is moving. 50 force apply on a 50 kilogram object. Do you see how it moves? Okay, now let's start afresh. See how it moves already. Now let's increase the force apply to 100. This is 100. Let's start the stopper. Before it comes to an end, we see how fast it's moving. 50 force apply is 100 on a 50 kilogram mass. So when it gets to the end, we shall pause the video. Boom, very good. So on record, we can record that it uses 17 seconds. 17 seconds, and the speed here was 39.9 meters per second. And the force applied here, the force is 100 newtons. The mass of the object, we can see the mass of the object here is 50. Now, let's see, shall we increase the mass? Let's increase the mass and see. Let's give the mass just 100 kilograms. 100. So we increase the mass to 100. The 50 plus 50 is 100. So this is the weight or the mass, how heavy the object is. And we are going to push it and see. Now, shall we start? Boom, let's start. The same 100 kilometers. Can we see how it's moving? Now it's not moving as the first time. The first, when it was 50, it uses 39.9 meters per second, and the time was 17. That's the total time. Now we increase this to 100, means that it's heavier than the first one. Let's see how to be the result. It's moving, the time is moving. Now can we see it's moving? Now it's 36, 40. Boom. We pause everything. So what happened? We can observe that when the mass has increased, the time at which it reaches its end, it uses now 40. The time at before it gets to 40, it uses more time. So it wastes a lot of time. It needs more energy, more time to work. So the force applied here is slower than the first one. Let's do the last analogy and see. Let's load it. Remove this. You send this one. You send the man. You carry his son, his daughter. So 200 plus 20, 280. 280 plus 40, 320. So the mass now is 320. Let's use the same 100 newtons and see what will be the force applied. So shall we start? Let's give it 100 newtons. We can see it's moving very, very slow. Can see how slow it's moving. We increase the mass at the same force. It's moving very, very slow. Can we see how slow it is? Now it means that when the mass of a body is directly proportional to the force. If it increases in force, if the mass increases, it affects the force applied. But if the mass is reduced, so shall we reduce the load? Can we see differences in the speed? How it's moving? Come down. Can we see how it's moving now? Now it's moving faster. Can we observe that? Now, the last analogy to end, we use our we add this. Okay, let's do 250. Now, shall we push 200 newtons? Shall we increase more? 250, 300. You see how it's moving? Quite faster. Let's reduce the mass and see what will be the effect. Woo! See how fast it's moved now? Now, when we reduce the mass, it moves very, very fast. This explains that force applied, the more that the mass is directly proportional to the force. So when we increase the mass, it affects the force applied. In real life situation, if you are asked to push a pickup, if two men are pushing a pickup on a level ground, it moves at a certain speed. If you load the pickup or the basket with a sand or a sand, you can attest that it has increased in mass. The rate at which it moves will not be as faster as the first one. So in a nutshell, this is where we end the lecture. If you have a question, you can ask. Thank you so much for understanding. Thank you so much for watching. Okay, see you in our next objective. Thank you so much.
Which is the second objective. How does force influence on object to move? We are going to show that. After the simulation, the third objective. Welcome to the third objective. So as a recap, we say force is a push or pull of an object. As you can see, what is it doing? It's pushing. This one is what? Pulling. So push here, pull here. So all these movements of objects is being influenced by force. This is by frictional force. This is by pulling forces applied here, drag force, magnetic forces, spring forces, or tensional force. So all these objects are what to define in the concept in the domains of force. So all these objects or activity going on here, force has been applied. So we are using diagram to show you how force is applied in daily life. If you move, you're able to come here to the class because you apply certain force to your body to move. Now, let's continue. Let's do some calculation. Third objective, we are going to look at the calculation of force of a body. So what is given by a force given by mass times acceleration? You can see the cursor. This mass, this acceleration. The mass is measured, the SI unit of mass is kilogram or gram. Acceleration is meters per second squared. This is how we write it. Meters per second squared. SI unit is Newton, as I said earlier. Shall we look at this example? A toy car of mass 5 kilograms accelerates 2 meters per second squared. What is the force applied? So we know the mass, we know the acceleration. So obviously the car was able to move. When it was able to move, as evidence of force has been applied. So what happened? We calculate the force by multiplying the mass times acceleration, get the 10 newtons. This is 10 newtons. When we write 10 capital N at every science student, every student know that this is 10 newtons. It's about what? A value of force. Thank you. Let's do the next question. Next question is that a 5 kilogram object is pushed and accelerates 4 meters per second squared. What is the value of the force acting? Now, write down the value of the force. We can all do this. I'll give you just 2 or 3 minutes. I'll give you just 1 minute to do this. 60 seconds. We can all do this. So we know what's the value of the force. You write it down. Write the value of the acceleration from the question and calculate the force. We can all do this. So I'm giving you, my clock is ticking. In 1 minute, 60 seconds, we can do that and give the answer. Group 2, second group over there, take the next question. So first group, take question 1. Second group, take question 2. A man pushes a rock of mass 100 kilograms. If the rock accelerates 10 meters per second squared, calculate the force of the man. So the question says A, write down the value of the force. So from the question, are you given a force? What the value? Write the value of the force in the question. Okay, write down the value of acceleration. This is quite harder. The boys there, you should do it for me. The boys at the back, this one is for you. Obviously, if you finish here, you come to this question. Write the value of the acceleration and calculate the force. As usual, you take the formula, you substitute, give it the answer. You finish, you submit your work for me. You keep it, I'll go around and mark. I'll go around, we'll look at it. Let's go to the next slide. Now, in a nutshell, we've explained that what causes object to move from the simulations. We say the greater the force applied on an object, the faster it moves and vice versa. That one is true. We saw from the simulations, when the force applied is greater, the object moves faster. So for example, the harder you kick a ball, the faster it moves. This is logic, simple science. That one is true. It's easier to push an empty cart. It is very light than full of heavy groceries. That one is, it's simple. It's simple. It's simple. It makes sense. Any question from the class? Any question? I'll go around, say the question. Now, as you can see, you take this to your homework. I'll give the first one. I've solved it for you. Go through. It's about 3 minutes to go. At about 1 minute, 1 minute to go. So this is your exit ticket. You take this. Okay, this is your exit ticket now. This is your homework problem of the day. Calculate the force applied on a car of mass 1,000 kilograms, which accelerates 20 meters per second. Everybody copy this. I'll send it to you. Those who are not in the class, put it in your Google Classroom or your Schoology. You open it, you solve it. The next time we meet next week, the first thing is you must finish the work and I must get the response in my answer it to the Google Classroom and I'll get a response. I'm going to grade it. It's gradable. Thank you for watching. Thank you. for cooperating. Thank you. Bye-bye.